If someone offered you a time machine tonight, you would not go forward. You would go back. Back to a room, back to a face, back to the moment before something broke. That is what almost everyone means by time travel, and it is the one version of it that physics is least sure it can ever give you. Here is the part that will keep you up. Going forward is the easy direction. It is real, it is measured, and it is merciless. Hover for a few hours beside a black hole, and you could return to find that thousands of years have passed on Earth, everyone you knew long gone. Twins have already come home from space no longer quite the same age. But every one of these doors opens one way only. You can leap ahead, you may never come back. We can go back is the oldest wish there is, and tonight we're going to press it against the actual laws of the universe and find out whether it is a real possibility or only a prayer. Make yourself comfortable. Hit subscribe if this is your first time here. Because by the end of this, the one direction you long for most is going to look completely different than it does right now. Now, let's gently fall into this. Part 1. The word you think you understand. You already know what time travel is. You have seen it 100 times in films and in old paperbacks, and you have quietly filed the whole idea in the same drawer where you keep dragons and starships and every other lovely thing that could never actually happen. Someone steps into a machine, a light flares, a clock spins backward, and they walk out into another century. That is the story, and because it has always been a story, you have learned to treat the entire subject as a kind of decoration, something the imagination reaches for when an ordinary afternoon gets too quiet. So let me begin by taking that certainty gently away from you, because the truth turns out to be far stranger than the fiction, and it starts with something you can check against your own wrist. You are time traveling right now. You're doing it as you listen to these words steadily, without effort, without a machine, moving into the future at a rate of exactly 1 second per second. That sounds like a joke or a trick of language, but hold on to it, because by the end of tonight that little phrase, 1 second per second, is going to mean something enormous. For the moment, just notice that the future is not a place you are waiting to reach. It is a place you are already falling into, every heartbeat carrying you somewhere you have never been, a moment you cannot return from, a version of the world that did not exist an instant ago and will never exist again. The real question, the one worth staying awake a little longer for, was never whether time travel is possible. The real question is which directions are open. Because it turns out that time, unlike the road outside your window, is not a two-way street. One direction is not only possible, it is guaranteed, unavoidable, happening to you and to everyone you have ever known at every moment. The other direction is the one every one of us actually wants, and it is the one the universe seems to have built its defenses around. When people dream about time travel, they almost never dream of going forward. They dream of going back. Back to a room, back to a face, back to the moment before a phone rang, back to the word they wish they had said, or the one they wish they had swallowed. The whole ache of the idea lives in 2 small words that people have whispered for as long as there have been people. We can go back. We can go back and fix it. We can go back and see them again. Tonight we're going to test those 2 words against the actual laws of physics, and I want to be honest with you from the start about where that test leads, because it is not where you would guess. The part of time travel that belongs in science fiction, the leap forward into a distant age, is real. It has been measured. It is running inside the phone next to your bed at this very second. And the part that feels like it should be the easy one, the sentimental one, the trip home to a moment that already happened, is the part that our deepest theory of space and time cannot quite forbid and cannot quite allow. The part that hangs in a genuine gap in human knowledge, guarded by paradoxes and by exotic ingredients the cosmos may simply refuse to hand over. The terrifying truth about time travel is not a monster, and it is not a machine. It is the shape of the thing. It opens one way, and the way it opens is not the way your heart wants to go. Let me make that phrase, 1 second per second, feel like something rather than sound like nothing. Right now, without any effort on your part, the present moment is dissolving into the past, and a brand new present is arriving to take its place, over and over, tirelessly, whether you attend to it or ignore it, whether you're happy or afraid. There is no pause button. There is no way to hold still in time the way you can hold still in a room. Even lying perfectly motionless in the dark, you're being carried forward, and the moment you're in as you hear this sentence will, before the sentence ends, be gone, unreachable, filed away in a past you can remember but can never revisit. That relentless, gentle forward motion is the most familiar experience a conscious being can have, and it is also, when you look at it directly, the single most mysterious thing about being alive. You are always leaving. You never arrive. You're perpetually falling into a future you did not choose and cannot refuse. Consider how strangely you are already built to live in time, and how one-sided that building is. You can remember the past in extraordinary detail, the smell of a room from childhood, the exact tone of a voice, a conversation from years ago, and you cannot remember the future at all, not 1 second of it, no matter how hard you try. You can act to shape what is coming, but you can only ever watch what has already been. Your whole mind is a device tuned to one direction of time, receiving the past, reaching toward the future, and it feels so natural that you never stop to ask why it should be so lopsided. Why can you touch yesterday with memory but not tomorrow? Why does the arrow of your own experience point so firmly one way? These are not idle questions. They turn out to be tangled up with the deepest puzzles in physics, with the reason heat flows from hot to cold and eggs break but never mend, and with the reason the future feels open and the past feels fixed. You live inside that asymmetry so completely that you mistake it for the simple nature of things. Before we go any further, let me tell you who you are about to meet tonight, because this is not going to be a story about imaginary machines and made-up heroes. You're going to meet a cosmonaut who has, by a measurable amount, lived less time than the rest of us, and who holds the record for it. You're going to meet a pair of identical twins who are no longer quite the same age, and the reason is written into the laws of physics rather than into anything they did. You're going to stand at the edge of a black hole where an afternoon swallows 1,000 years, and then you're going to follow a logician into a spinning universe he built out of pure mathematics and handed to Einstein as a birthday present, a universe in which you could visit your own past. And near the end, you're going to sit in a quiet room where a great physicist once threw a party for travellers from the future and waited among the empty chairs to see if anyone would come. Every one of these is real. Every one of them is documented. None of it requires you to believe a single thing that has not been measured or written down or worked out in the honest mathematics of our best theories. I promise you this because time travel has been buried so deeply under fiction that its real face has been almost forgotten, and the real face is stranger and more moving than any invention. So let go of the machines with the flashing dials and the spinning clocks. What we are actually going to talk about is quieter and closer, and it has been true your whole life without your permission or your notice. You're moving through time right now. The only question is what the rules of that motion really are. And notice, before we begin in earnest, how gently the whole thing is already happening. There is no roar, no flash, no lever to pull. You're simply here, and then you are here a moment later, and the moment you were in has quietly become somewhere you can never return to. It happens while you breathe, while you listen, while you do nothing at all. The most ordinary experience you have ever had, the plain passing of time, is also the one piece of time travel that no one can deny, and it is carrying you, right now, at that steady rate we're going to keep coming back to, 1 second for every second, into a future that is always arriving and never quite here. And that is exactly why the idea of going back has such a grip on us. We are creatures who can vividly recall what we have lost and are utterly unable to return to it. And that combination, perfect memory and total inaccessibility, is a recipe for longing. The past is right there, clear as a photograph and sealed behind glass. So when someone says the words "we can go back," they are not describing a technology. They are naming the oldest human ache there is, the wish to walk back into a picture you can still see perfectly and can no longer enter. Tonight we're going to ask whether the glass is truly unbreakable, or only very, very hard, and the answer will take us to the edge of what physics knows. Part 2. Time is not a river everyone shares. For almost all of human history, everyone assumed that time was a single thing that happened to everybody at once. There was a universal now, a cosmic clock ticking somewhere behind the world, and every event on Earth or on the far side of the sky either happened before that tick or after it. Isaac Newton wrote this assumption into the foundations of physics in the 1600s, and he did not really argue for it because it did not seem to need arguing. Time flowed, he said, equably, the same for all, indifferent to what anyone was doing. An hour was an hour whether you spent it running or sleeping, Whether you are standing still or riding the fastest horse in the world, this is still how time feels to you. It feels like a river you and everyone else are floating down together, all of you carried at the same speed, all of you sharing the same present moment. It is one of the most natural beliefs a human being can have, and it is wrong. In the year 1905, a 26-year-old patent clerk named Albert Einstein noticed that this comfortable picture could not be true, and the reason came down to light. Experiments had shown something impossible about light, something that should not fit together. No matter how fast you move toward a beam of light or away from it, you always measure it travelling at exactly the same speed, just under 300,000 kilometres per second. That does not sound alarming until you sit with it. If you run toward anything else, a thrown ball, a passing car, it comes at you faster. If you chase it, it comes at you slower. But light refuses to play along. Sprint toward it, flee from it, it does not matter. The beam always arrives at the same unchanging speed. Einstein realized that for this one stubborn fact to be true, something else had to give, and the thing that gave was the last thing anyone expected. It was time itself. Here is the bargain the universe strikes, and it is worth saying slowly. Speed and time are traded against each other. The faster something moves through space, the slower it moves through time. Not slower in the way a bored afternoon feels slow, slower in the sense that its clocks, all of its clocks, the ticking of a wristwatch, the vibration of an atom, the beating of a living pulse, literally run down compared to yours. Physicists call this time dilation, and there is a number that measures it. The number is usually written as the Greek letter gamma, and you do not need the equation, you only need the shape of it. At the speeds you live your life, walking, driving, flying in a jet, gamma is so close to 1 that the slowing is utterly invisible, a difference buried dozens of decimal places down. That is why no one noticed for all those centuries, but as you push toward the speed of light, gamma starts to climb, and then it starts to soar. Let me give you the ladder, because feeling the shape of it matters more than any single rung. If you could travel at 1/10 of the speed of light, already unthinkably fast, thousands of times faster than any rocket ever built, your clock would run slow by only about half of 1%. Barely anything. But keep pushing. At roughly 87% of light speed, gamma reaches 2, which means your time runs at half the rate of the world you left behind. For every hour that passes for you, 2 hours pass for everyone else. Push on to 99% of light speed and gamma is about 7. Now for every year that passes on your ship, 7 years pass on Earth. At 99.9%, gamma is about 22. At 99.99%, it is about 70. The closer you press to that wall of light, the more violently the ratio tilts, until the smallest sliver of extra speed buys you decades, centuries, ages of the outside world. Time is not a fixed river carrying everyone at one pace. It is something you can spend faster or slower depending on how you move, and the exchange rate becomes ferocious near the edge. Here is a way to feel how completely the shared present collapses. Suppose that far across the galaxy, 2 stars flare at what you would call the same instant, one on your left, one on your right, perfectly simultaneous as far as you're concerned. Now suppose a traveller drifts past you at that very moment, moving at high speed toward the star on your right. For that traveller, the 2 flares did not happen at the same time at all. The star on the right flared first, the star on the left flared later, and the traveller is every bit as correct as you are. There is no experiment either of you could perform to settle which of you is really right, because the question has no answer. Simultaneity, the very idea that 2 distant things can happen at once, turns out not to be a fact about the universe, but a fact about your particular motion. Change your motion, and you change what counts as now. There is a simple picture that shows exactly why motion slows a clock, and it uses the strangest fact about light as its engine. Imagine a very simple clock, one made of nothing but a beam of light bouncing straight up and down between 2 mirrors, 1 tick for each round trip. When this clock sits still beside you, the light goes straight up, straight down, and the ticks come at a steady rate. Now set that same clock moving sideways, fast, past you. From your point of view, the light no longer travels straight up and down, because between the moment it leaves the bottom mirror and the moment it returns, the whole clock has slid sideways, so the beam has to travel a longer slanted path, up and over and back down, a stretched zigzag rather than a straight line. But here is the fact that changes everything. the speed of that light does not increase to cover the longer path. Light always travels at the same fixed speed, no matter who is moving, and if the light must cover more distance at the same speed, then each tick must take longer. The moving clock ticks slower, not because anything is broken, but because the one thing that cannot change, the speed of light, forces time itself to give. It is worth pausing on how much nerve it took to say what Einstein said, because from the outside it looked like madness. Here was a young man with no professorship, no laboratory, no telescope, working as a clerk in a patent office, and thinking in his spare hours, and what he proposed was that the most basic framework everyone had always taken for granted, a single universal time ticking the same for all, was simply wrong. Not slightly off, wrong at the root. He did not arrive there by measuring anything himself. He arrived there by taking one strange fact about light with total seriousness and refusing to flinch from where it led, even when it led somewhere that overturned common sense. That is the move that changed physics, and it is worth admiring, because most people, faced with a fact that breaks their picture of the world, quietly set the fact aside. Einstein did the opposite. He kept the fact and threw away the world. And the world he threw away is the one you still carry around in your head, the world of a shared present moment. You cannot help it. Your whole life runs on the assumption that there is a real now, that everyone is in together, that when you think of a friend far away, they are living through the very same instant you are. Relativity says there is no such shared instant, that now is a local and personal thing, tilted slightly differently for everyone depending on how they move, and that no experiment could ever pick out a true universal present from among all the tilted ones. This is not a small technical correction. It is a completely different picture of what time is, and the only reason it does not shatter your daily life is that at the speeds you live at, the tilting is far too small to feel. But it is there. It is always there. And the proof, as I keep promising, is not subtle at all once you know where to look. This is the whole secret, and it applies to every clock, not just clocks made of light, because if one kind of clock slowed and another did not, you could compare them and catch the difference, and the universe does not permit that. Every process slows together, the bouncing light, the swinging pendulum, the vibrating atom, the chemistry of a living body, all of it, in perfect lockstep, so that from inside the moving frame nothing seems amiss at all. Time itself is what has changed, not any particular clock. Newton believed there was a single master time behind the world, ticking for everyone. Einstein showed there is no master, only this bargain, struck freshly for every moving thing, that the constancy of light must be preserved even if the flow of time has to bend to preserve it. And it does bend, exactly enough, always. The proof of it is not a fragile laboratory curiosity, and I keep promising you the sky, so let us finally go up and look. Part 3. The proof is raining on your head. It would be fair at this point to be skeptical. Everything I have just told you runs against a lifetime of experience, and extraordinary claims deserve to be doubted until something forces your hand. So let me force it, not with a thought experiment, but with a rain of real particles that would not reach the ground at all if time behaved the way it feels like it behaves. High above you, right now, far past the clouds, the top of the atmosphere is being struck by cosmic rays, fragments of atoms flung across the galaxy, by exploding stars and other violence, arriving with staggering energy. When one of these strikes an air molecule about 15 kilometers up, the collision shatters into a spray of new particles, and among them is one called the muon. A muon is a heavier cousin of the electron, and it has one important quality for our purposes. It is unstable. Left to itself, a muon survives, on average, only about 2.2 microseconds, 2 millionths of a second, before it decays into other particles and is gone. That is its whole lifespan, measured in a laboratory again and again with great care. 2.2 microseconds. Now do the arithmetic that any physicist in the early 20th century could have done, using ordinary common sense about time. These muons are born 15 kilometers up. They are moving downward at very nearly the speed of light, which is fast, but even at that speed, in 2 millionths of a second, a muon can only cover a few hundred meters before its time runs out and it falls apart. A few hundred meters out of 15,000. By every reasonable expectation, essentially none of them should ever reach the ground. They should wink out of existence high in the air, thousands of meters above the tallest mountain, long before they get anywhere near you. The sea-level world should be almost completely free of them, but it is not. Muons pour through the ground, through the roof, over your head, through your body, at a steady, measurable rate. Hold out your hand and roughly 1 muon passes through it every second or so. They arrive in enormous numbers, vastly more than should have survived the trip, and physicists have measured exactly how many, and the discrepancy is not small or subtle. It is a factor of many, many times more survivors than the simple calculation allows. Something is keeping them alive far longer than their 2.2 microseconds should permit, and that something is time dilation, exactly as Einstein described it. From where you stand, the muon's internal clock is running slow because it is moving so close to light speed. Its 2.2 microseconds of life, measured on its own clock, stretches, from your point of view, into far more than enough time to complete the journey to the ground. It is, in the most literal sense the words can carry, travelling into its own future more slowly than it should, and that extra borrowed time is what lets it survive to reach you. In 1963, 2 physicists named David Frisch and James Smith made this beautifully concrete. They carried muon detectors to the top of Mount Washington, a peak in the northeastern United States standing nearly 2,000 meters high, and counted how many muons arrived there in an hour. Then they measured how fast those muons were moving, around 99.5% of the speed of light. Then they brought their equipment down to sea level and counted again. Common sense, the old Newtonian river, predicted that almost none should survive the extra distance. Relativity predicted that most of them would, because at that speed their clocks were running at a small fraction of the mountain's clock. The mountaintop count and the sea level count came back, and relativity was right, down to the number. There is another way to tell the muon story, and it is worth telling, because it shows that both sides of the exchange agree even though they describe it completely differently. I told you the tale from your point of view, standing on the ground, watching the muon's clock run slow so that its brief life stretches long enough to finish the trip. But now ride down with the muon itself. From the muon's own perspective, its clock is perfectly normal. It lives its ordinary 2.2 microseconds, no more, exactly as it would in a laboratory at rest. Nothing about its own experience is stretched. So how does it reach the ground? Because from the muon's point of view, something else has changed instead. The distance to the ground is not 15 kilometers. Moving so close to light speed, the whole atmosphere ahead of it is squeezed, flattened, compressed to a small fraction of its usual thickness, so that the journey the muon must complete is short enough to finish in the little life it has. You say it's time stretched. It says your distance shrank. You're both right, and you both agree, in the end, on the one thing that can actually be checked. The muon reaches the ground. The muons falling through the atmosphere are not the only place we catch time in the act of slowing, and the others are just as decisive. In the great rings where physicists accelerate particles to nearly the speed of light, they routinely watch unstable particles live far longer than they should, stretched by exactly the factor relativity predicts, so reliably that the effect is not a discovery anymore but a tool, something engineers simply account for the way a carpenter accounts for the thickness of a board. Muons whipped around a storage ring at close to light speed have been clocked surviving dozens of times longer than a muon sitting still, and the number matches the theory to remarkable precision, again and again, in laboratory after laboratory, decade after decade. There is no serious doubt about any of this. Time dilation is one of the most thoroughly confirmed facts in all of physics. It is not on trial, it is furniture. Let the scale of it land, because the numbers make the point sharper than any argument. Without time dilation, the fraction of these atmospheric muons that should reach the ground is so small it is very nearly none, a mere handful surviving out of every group that started the journey. With time dilation, the fraction that actually arrives is enormous by comparison, the great majority making it all the way down. The gap between those two predictions is not a matter of a few percent that could be argued away. It is a chasm, a difference of many times over, and every measurement ever made falls on the side relativity predicted. You could stand in an open field on any clear night, holding a detector, and watch the universe settle the question in your favour, over and over, particle after particle, each one a tiny witness to the fact that fast things move through time more slowly than you do. And here is the thread that ties this humble particle to everything still ahead of us tonight. The exact same effect that keeps a muon alive long enough to reach the ground is the effect that would let a person, moving fast enough, skip across years or centuries of the world's history. There is no separate physics for particles and for people. The muon and the astronaut and the twin on the near-light-speed ship are all doing the identical thing, riding their own slowed clocks into a future that arrives for them more slowly than for everyone they left behind. The muon does it by a hair, invisible and constant in the dark air above your roof. Turn that hair into a mile, push the speed close enough to light, and the same gentle slowing becomes a leap across ages. That is the promise and the warning folded into every one of these silent arrivals, and it is why the next question is no longer about particles at all, but about a person and a journey and a homecoming. What I want you to carry out of this part is not the data, but the feeling of the data, the quiet vertigo of it. Above your roof, in the dark, particles are living stretched lives, arriving where they should not, because their passage through time has genuinely slowed. It is not rare, it is not delicate, it is the ordinary weather of the universe, happening in the air of your bedroom as surely as it happens in a laboratory ring, and it has been happening every second of every night of your entire life without your ever feeling it. The future is not something the universe is saving up to give you later. It is something you and every particle around you are pouring into constantly, each at its own rate, and the rates are not the same. Once you truly believe that for a muon, you have no honest choice but to ask what it would mean for a person, for a body, for a life, and that question has a face on it, a pair of faces, twins standing on a launch pad, and it is where we go next. Part 4. The twin who came home younger. Imagine two sisters, identical twins, standing together on a launch pad. They have shared everything, the same birthday, the same face, the same number of days lived down to the hour. One of them is about to leave. She climbs into a ship capable of travelling at a large fraction of the speed of light, and she sets off toward a distant star, a journey out and a journey back. The other sister stays home, keeps her job, waters the plants, watches the news, and waits. Years pass on Earth. And when the ship finally lands and the traveller steps out and the two sisters stand face to face again, they are no longer the same age. The one who travelled is younger, visibly, undeniably younger than the one who stayed. Not younger in spirit, not younger in some poetic sense. Younger in years lived, in wrinkles, in the count of birthdays her body has actually experienced. She has been away, by her own reckoning, for perhaps a handful of years. Her sister has waited decades. This is the famous scenario physicists call the twin paradox, first laid out in this form by a French physicist named Paul Langevin in 1911, and I want to be careful with the word paradox, because it makes the whole thing sound like a puzzle with a catch, a riddle where somebody's being fooled. It is not. Nobody is fooled. The travelling twin really does come home younger. The difference in their ages is real and permanent, and if you built the ship and ran the trip, it would happen exactly as described. What makes people call it a paradox is a reasonable objection that occurs to almost everyone the first time they hear it, and the objection is worth taking seriously, because chasing down why it fails is how you truly understand what time dilation means. The objection goes like this. Motion is relative, isn't it? From the point of view of the sister on the ship, she is sitting still, and it is the Earth, with her twin on it, that goes speeding away and then comes racing back. So why can't we tell the story from her side and conclude that the stay-at-home sister should be the younger one? If everything is symmetric, if either twin can claim to be the one at rest, then how can there be any real difference at all when they reunite? It sounds airtight. And the answer to it reveals something important. The two situations are not symmetric, and the asymmetry is the whole key. The twin who stays on Earth remains in one steady state of motion the entire time. The twin who travels does not. She has to fire her engines and accelerate away from Earth. She has to slow down, stop, and turn around at the distant star. She has to accelerate again to come home, and she has to brake to land. She feels every one of those changes pressed back into her seat, her stomach lurching, while her sister on Earth feels nothing of the kind. Only one of them changes her state of motion. Only one of them takes the trip that bends away from a straight path through space-time and then bends back. And that one, the one who turned around, is the one who ages less. There is a lovely way to picture why. Think of the two sisters as tracing two different routes between the same 2 points, the goodbye on the launch pad and the reunion when the ship returns. The stay-at-home sister traces the straight direct route through time. The traveller takes a longer bent route out through space and back, and here is the counterintuitive part that relativity insists upon. In the geometry of space-time, the path that looks longer, the one that loops out into space and returns, is actually the path along which less time passes. Moving through space costs you time. The more of your journey you spend racing across distance, the less of it you spend aging. The travelling twin spent a great deal of her journey moving through space at enormous speed, and so she spent correspondingly little of it moving through time. She did not cheat the clock. She took a route through reality along which fewer seconds were there to be lived. It helps to sit with why the bent path is the shorter one in time, because it runs so hard against instinct. In the ordinary geometry you learned as a child, a straight line is the shortest distance between 2 points, and any detour makes the trip longer. Space-time plays by a stranger rule. When it comes to the time you actually live through, the straight, unhurried path, the one the stay-at-home twin takes, is the longest, and any detour out into space and back is shorter. Every bit of speed you pour into crossing space is subtracted from the time you get to experience. The travelling twin, by hurling herself across enormous distances at enormous speed, spent her journey trading away her own hours, and she arrived having lived fewer of them. It is not that her clock malfunctioned or that she was tricked. She genuinely took a path through reality along which less life was available to be lived, and she lived all of it, and it added up to less. It is worth noticing that the twin paradox is not only a thought experiment, because in a small way it has already been performed, and the travelling twin was a clock. When those atomic clocks were flown around the world on jets and came back disagreeing with the clocks that stayed home, that was a twin experiment in miniature. The flying clock is the sister who travelled. The ground clock is the sister who waited. They began in perfect agreement. They were separated, one of them moved, and when they were brought back together they no longer told the same time, by an amount that matched the prediction to within the precision of the measurement. The only reason the effect was measured in billionths of a second rather than in years is that a jet is unimaginably slow compared to light. The principle is identical. Speed up the plane to near light speed, and the billionths of a second become the decades of the story. The reunion on the launch pad is not a fable dressed up as physics. It is the flying clock experiment with the dial turned all the way up. Let me put real numbers on the travelling twin, because they turn the fable into something you can almost feel the weight of. Suppose the ship can reach a speed where its clock runs at 1/10 the rate of the clocks back home, a factor of 10, which requires travelling at about 99.5% of the speed of light, fast but well within what the physics allows. Now send the traveller to a star that is, say, 20 light-years away, and bring her home. From Earth's point of view, light itself needs 20 years to make that crossing, so the round trip out and back takes something over 40 years of Earth time no matter what. Her sister who stayed home ages those full 40 years and more, but the traveller, with her clock running at 1/10 the rate, experiences only about 1/10 of that. She comes home having lived roughly 4 years, while her sister lived more than 40. She left a young woman and returns a young woman, 4 years older, to a sister nearing old age. That is not a rounding error or a laboratory curiosity measured in billionths of a second. That is a person stepping off a ship 4 years older than when she left, and finding that 4 decades have poured through the world in her absence. Everything about it is permitted, calculated, consistent with everything we have ever measured. The only reason no human has done it is that we cannot yet build a ship that fast, not that the universe forbids the outcome. And notice, once more, the shape of the thing, because it will haunt the rest of tonight. She travelled into the future, genuinely, arriving in a later year than she could have reached by waiting. And she cannot go back. The 40 years her sister lived are simply gone for her, unreachable, a stretch of her sister's life she was not present for and can never attend. The door she walked through only opens one way, and that one-way quality is not a limitation of her ship. It is a property of time itself, and it is real enough that human beings right now have already tasted it. The objection people always raise, that motion is relative, so each twin should see the other as the one who moves, dissolves, the moment you ask a single concrete question. Who felt the turnaround? Only one twin fired her engines and was pressed into her seat as the ship swung around the distant star to come home. Only one of them changed her state of motion, and that breaking of the symmetry is not a matter of opinion, it is a physical event she can feel in her body and measure with any instrument aboard. The stay-at-home twin coasted in a single unbroken state the entire time. The traveller did not. That is the whole asymmetry, and it is why there is a definite answer to which twin comes home younger, and no genuine paradox at all, only a deep truth wearing a puzzle's clothing. And the truth is that a real person, moving the right way, would really return to find the world age past them, which is no longer even hypothetical, because real people have now done exactly this, and one of them holds the record. Part 5. The people who have already travelled. There is a man alive today who has travelled further into the future than any other human being who has ever lived. His name is Sergei Krikalev, and he is a retired cosmonaut, one of the most experienced space travellers in history. Across a career that spanned 6 long missions, he spent a cumulative total of roughly 803 days in orbit, more than 2 years of his life circling the planet at a speed of about 7.5 kilometers per second. That is nowhere near the speed of light, of course. Compared to a beam of light, it is a crawl, but it is fast enough, sustained for long enough, that time dilation left a mark on him that can actually be calculated, and the calculation gives a real, specific answer. Because he spent so long moving so quickly relative to the people on the ground, Sergei Krikalev aged very slightly less than he would have if he had simply stayed home. When you add up all those days at orbital speed, the shortfall comes to about 1/50th of a second, roughly 20 milliseconds. When he returned to Earth for the last time, he stepped off into a world that was about 1/50th of a second further into the future than his own body had experienced. He had, quite literally, skipped forward in time, past a sliver of the universe's history, and arrived on the far side of it younger than he should have been by exactly that margin. It is a tiny number. You could not feel it. You could not measure it with any clock you own. But it is not zero, and it is not a metaphor, and it is not rounding error. It is signed and it is real, and it makes Sergei Krikalev the current world record holder for time travel into the future. A human being has done this. It is in the books. If 1/50th of a second sounds too small to matter, I understand, but I want you to resist the urge to shrug it off, because the size of the number is not the point. The direction of it is the point, and the certainty of it. We are not debating whether forward time travel can happen. We are down to negotiating how much. The effect is on the menu of what the universe permits, fully confirmed, and the only thing standing between 20 milliseconds and 20 years is speed. Krikalev did it at a walking pace, cosmically speaking. Push a traveller to a real fraction of light speed and that 1/50th of a second becomes a decade, becomes a century, becomes as far forward as you have the fuel to throw yourself. There is another case that makes the strangeness even more personal, because it involves 2 people who are supposed to be identical. In the years around 2015 and 2016, an American astronaut named Scott Kelly spent 340 days living aboard the International Space Station, a nearly year-long mission, while his identical twin brother Mark, also an astronaut, stayed on the ground. This was, among other things, a rare natural experiment. Here were 2 men with the same genes, born minutes apart, one of whom was about to spend most of a year moving fast in orbit, while the other stayed still, and when Scott came home, the twins were no longer quite the same age. Scott had aged a few milliseconds less than Mark over the course of that mission. The difference is minuscule, far too small for either brother to notice across a dinner table, but it is there. 2 men who began life within minutes of each other, who had been the same age their entire lives, ended a year apart in space with clocks that no longer perfectly matched. One brother is now, permanently, a few thousandths of a second younger than his twin, and he earned that gap by leaving the planet. Think about what this quietly does to the word age, a word you have used your whole life as if its meaning were obvious. You have always treated your age as a fixed fact, a number that ticks up once a year no matter what. The same for you as it would have been in any life you might have led. It is not. Your age is a running total, the sum of every second your own particular path through the universe has actually contained, and that total depends, in a real, if usually tiny way, on how you have moved. Every mile you have ever driven, every flight you have ever taken, has pulled your personal clock a hair's breadth behind the clocks of people who stayed still, so that you are, this very instant, a vanishingly small fraction of a second younger than you would have been had you never left your chair. You will never feel it. It will never matter to your life. But it is true, and its truth is the same truth that would let a fast enough traveller skip 1,000 years. The difference between you and the time traveller of legend is not a difference of kind. It is only a difference of degree. Sergei Krikalev's story carries an extra weight of history that makes his sliver of a second feel larger than it is. During one of his long stays aboard a space station, the country that had launched him, the Soviet Union, ceased to exist beneath him while he orbited. He went up as a citizen of one nation, and the map changed while he was weightless above it, so that the world he returned to was politically a different world from the one he had left, quite apart from any physics. There is something fitting in that. A man who travelled a measurable distance into his own future also returning, in a human sense, to a changed country, an altered present. The ground shifted under him in more ways than one. Across all his missions he logged more time moving fast, high above the Earth, than any other person, and so the tiny relativistic debt accumulated second by orbital second, until it added up to the largest forward jump any human clock has yet recorded. Roughly 1/50th of a second, earned the slow way, by living more than 2 years at orbital speed. You do not have to be a cosmonaut to have done this, which is the quietly astonishing part. Every single time you have flown in an airplane, you have come back a few billionths of a second younger than you would have been had you stayed on the ground, because for those hours you were moving faster than the people below. The amount is so tiny that no clock you will ever own could show it to you, and it will never make the slightest difference to your life. But it is not zero, and it is not imaginary, and it points in a definite direction. You have, in the most literal and measurable sense the words allow, already travelled a sliver into your own future, more than once, without ever knowing it. The frequent flyer and the cosmonaut differ only in degree. Both have set their personal clocks a hair behind the world's by moving fast, and both have arrived, however slightly, ahead of where they would otherwise be. Hold that against the ordinary way you think about your own age, and feel how it loosens. You have always imagined your age as a fixed and simple fact, a single number that belongs to you and would be the same in any life you might have led. It is not. It is a running sum of the time your particular path has actually contained, and every journey you have ever taken has adjusted it, imperceptibly, in your favour. There is no master clock stamping the same age on everyone born in the same hour. There is only the total each of us accumulates along our own route through the universe, and those totals quietly diverge, by nanoseconds for the traveller on a plane, by a measurable fraction of a second for the cosmonaut, and by decades, in principle, for anyone who could ride a beam of near light. Forward time travel is not waiting to be invented. It is a thing you have already done, and the only frontier left is how much. The Kelly twins sharpen the same fact to a fine point, because they were meant to be a controlled comparison of two nearly identical human beings. One brother lived for the better part of a year moving fast in orbit while the other stayed on the ground, and when they were compared afterward, the one who had flown had aged a few thousandths of a second less. It is a difference no birthday party could ever detect, but it converts something abstract into something bodily. Here are two men, from the same womb, from the same instant, who were the same age their whole lives, and one of them is now permanently, if imperceptibly, younger than the other, and the reason is written in the laws of motion and gravity, not in anything either of them did to their health. Your age, it turns out, has a small print clause you never read, a term that depends on how you have moved through the universe, and if a gentle orbit can bend it by a sliver, then something far heavier and far more violent could bend it enormously, which brings us to the second door into the future, the one that asks you to move not fast but down. Part 6. Gravity is a Time Machine too. When Einstein finished his first theory in 1905, he had shown that motion bends time. It took him 10 more years, until 1915, to finish the larger theory that would show something even stranger, and this one reaches into a corner of your life you never think about. Gravity, it turns out, also slows time, not by making you move, but simply by being close to a large mass. The deeper you sit inside a gravitational field, the slower your clock runs compared to someone higher up, further from the mass, out where the pull is gentler. Sink toward a heavy object and your time drags. Rise away from it and your time quickens. Every one of us is living this out at every moment, and the difference between your head and your feet is real, if almost immeasurably small. Consider where you're lying right now. Your feet are slightly closer to the centre of the Earth than your head is, which means your feet sit a little deeper in the planet's gravity, which means, unbelievably, that your feet are aging very slightly more slowly than your head. Over a lifetime, the difference amounts to less than the width of a heartbeat, far too small to ever notice, but it is there, and it has been measured with clocks sensitive enough to detect the time difference across a single vertical step. Gravity is quietly stretching and compressing time up and down the length of your body as you rest. You're not a single clock, You're a whole population of clocks, each ticking at its own rate depending on exactly how far it sits from the mass below you. This is not a curiosity confined to laboratories. It is the reason the navigation system in your phone works at all. High above the Earth, roughly 20,000 kilometers up, a fleet of satellites carries atomic clocks, and those clocks feel two competing effects at once. Because the satellites move fast in their orbits, the motion tries to slow their clocks down, the effect from the first theory, and that alone would lose them about 7 microseconds per day. But because they sit high up, far from the bulk of the Earth, out where gravity is weaker, their clocks also run fast, gaining about 45 microseconds every day, the effect from the second theory. Add the two together, and the satellite clocks run a net 38 microseconds per day, faster than the clocks on the ground beneath them. That is 38 millionths of a second. A day, which sounds like nothing, until you realize that the whole system pinpoints your location by comparing the timing of signals down to the nanosecond. Left uncorrected, that 38 microsecond drift would throw your position off by about 10 kilometers every single day, and it would grow worse with every hour. The only reason the little blue dot lands on the right street is that the engineers who built the system baked Einstein's time distortion directly into it. Your phone assumes, correctly, that time runs at different rates at different heights above the Earth, and it finds you by trusting that assumption. Now push the idea to its limit, because this is where gravity becomes a genuine machine for reaching the far future. The effect grows stronger the denser and more compact the mass, and there is nothing in the universe more compact than a black hole, an object so dense that its gravity near the surface becomes almost unlimited. Imagine, then, a ship that flies to a black hole and takes up a position just outside the edge of no return, the event horizon, hovering there with its engines roaring to keep from falling in. On that ship, close to that monstrous mass, time slows to a crawl relative to the rest of the universe. And I want you to actually be there for a moment, because a number cannot carry this the way a picture can. It is strange to realize how thoroughly this hides inside ordinary life, so let me bring it down from orbit to the ground for a moment. Clocks have now been made so exquisitely precise that physicists can measure this gravitational slowing across a difference in height of a single step, a change of a foot or two in a laboratory. Raise one of these clocks up onto a low shelf and it will measurably begin to run faster than its twin on the floor because it has moved a little further from the centre of the Earth, a little higher out of the planet's gravity. A clock at the top of a tall mountain runs faster than a clock in the valley below it, and over a human lifetime the gap would amount to a sliver of a second. Time is not a single fixed rate that the whole world shares. It is a terrain of subtly different rates, faster where gravity is weaker, slower where gravity is stronger, draped over every hill and building and body on the planet. You live at the bottom of a gentle well, and time runs a touch slower for you than for the satellites overhead, and everyone has simply agreed not to notice. The measurement of gravity slowing time was first done not near any black hole, but inside a single building, and the smallness of it makes the reality of it more astonishing, not less. Physicists placed sensitive detectors at the bottom and the top of a tower just a few stories tall, and were able to show that time ran very slightly slower at the bottom, nearer the Earth, than at the top, exactly as the theory demanded, and this was managed with the crude instruments of many decades ago. Modern clocks have pushed the same measurement down to the scale of a raised hand. Lift the clock by the height of a single step, and it speeds up by an amount we can now actually read. There is no escaping the conclusion, however strange it feels. The rate at which time passes for you depends on how deep in gravity you sit, and every staircase in the world is, in the most literal and measurable sense, a gentle gradient of time, running a hair slower at the bottom step than at the top. The reason gravity slows time comes straight from the picture Einstein finished in 1915, and it is worth stating once, gently, because it turns the black hole from a curiosity into an inevitability. In that picture, mass and energy bend the fabric of space-time around them, and what we feel as gravity is really the shape of that bending. But it is not only space that bends. Time bends too, and near a large mass time is stretched, so that clocks deeper in the well tick slower than clocks higher up. The more extreme the mass, the more violent the stretching, and a black hole is mass taken to its absolute limit, so much of it packed so tightly that near the edge, time nearly grinds to a halt relative to the outside. This is not an exotic special case bolted onto the theory. It is the same effect that makes the satellites overhead run fast, simply turned up until it becomes monstrous. Everything in between, from a mountain to a planet to a collapsed star, sits somewhere on that single continuous scale of stretched time. So the black hole traveller is not doing anything the universe finds strange. They are doing exactly what your feet do, aging a touch slower than your head, because they sit a little deeper in the Earth's gravity, only carried to an extreme that turns a lifetime's imperceptible sliver into a gulf of ages. And when they climb back out and come home, the grief waiting for them is the same grief in every corner of this subject, the grief that forward motion always carries. They have not aged. The world has. Everyone is gone. The afternoon they spent beside the horizon cost them everyone they knew, paid out in the ordinary centuries that swept past outside while they hovered in their slowed pocket of time. The future door is real, and it is generous, and it is open, and every single person who has ever imagined walking through it has had to reckon, sooner or later, with the fact that on the far side of it, the people they love are not waiting. They are dust. And that is the catch we have to face directly now, because it is the reason the future, for all its open gates, is never what the heart is truly reaching toward. Now return one last time to the ship at the edge of the black hole, and let the arrival home land with its full weight, because this is the future door at its most extreme and its most merciless. You spent an afternoon beside the horizon, you climb away, and you turn for home, and the trip back is uneventful. But the Earth that rises in your window is not the Earth you left. The coastlines have shifted, the languages have changed past recognition. Whatever you were, whatever you did, whoever knew your name, all of it lies so far back in the planet's history that no trace of it survives in living memory. You did not age. You're exactly as you were that morning beside the black hole, and everyone, everything, the entire warm, crowded world you came from, is gone, dissolved into the centuries you skipped in a single afternoon. This is the gift and the price fused into one object. The future door is genuinely open, and stepping through it in earnest means arriving in a tomorrow that has no room in it for anyone you love, which is the quiet horror we turn to now, the catch that sits inside even the kind of time travel we can prove. Part 7. The One-Way Door. Everything I have shown you so far is a kind of gift, if you look at it a certain way. The universe will carry you into the future. It will do it for a particle, it has done it for a cosmonaut, and it would do it spectacularly for anyone who could travel fast enough or stand close enough to something heavy enough. You could, in principle, see the world of 1,000 years from now with your own eyes. You could skip the slow centuries and step out into an age your ancestors could not imagine. When people first understand that this is genuinely possible, that forward time travel is not a maybe, but a certainty waiting on engineering, there is a moment of real exhilaration. And then, if they keep thinking, the exhilaration turns quietly to something colder, because there is a catch built into the very shape of it, and the catch is the whole tragedy of the thing. You can go forward, you cannot come back. Every method we have found, the speed, the gravity, the racing ship, the black hole, carries you in one direction only, and once you have leapt ahead, there is no return ticket. The travelling twin who came home younger did not travel back to the day she left. She travelled forward, slower than her sister, and arrived in her sister's future still holding her own smaller pile of years. She cannot undo the trip. She cannot rewind to the launch pad and give those decades back to the sister who waited. The gap between them is permanent. When you use the future door, you are not visiting the future the way a tourist visits a city and then flies home. You are moving there, permanently. Everyone you leave behind keeps aging at their normal pace while you skip ahead, which means that by the time you arrive in that shining later age, everyone you knew has lived out the rest of their lives and died without you in the ordinary span of years, while for you almost no time passed at all. This is the quiet cruelty I promised you at the beginning. The fantasy of seeing the future sounds like adventure, but underneath it is something closer to exile. To jump forward is to abandon your own present, to walk out of the world you belong to and let the door close behind you. The faster and further you go, the more of everyone else's life happens in your absence, until the people you love are not waiting for you at the destination. They are simply gone, and the future you arrive in is full of strangers who have only heard of you, if that. The astronaut who spends a year in space to gain a few milliseconds pays almost nothing for it. But scale the trip up to the future worth seeing, the far one, and the price scales up with it. To reach the world of 10,000 years from now, you must give up every single thing and person in the world of today. There is no version where you get to see what comes next and also come home to tell the people you love about it. The people you love are the toll. Do the arithmetic of a real leap just once, because the numbers are where the loneliness lives. Say you found a way to travel so that a single year passed for you while 500 years passed on Earth, a modest trip by the standards of what the physics allows. You step off your ship 1 year older, still yourself, still young, ready to see the marvels of the 5th century from now, and everyone you have ever loved has been dead for centuries, not waiting, not older, gone, and their children gone, and their children's children gone, the whole warm crowd of your actual life erased by the ordinary passage of the years you skipped. The future you travelled to does not contain a single face that would light up at the sight of yours. You did not take a trip. You emigrated to a country of strangers and burned the bridge behind you in the leaving. The exhilaration of seeing the future and the desolation of arriving there alone are not two different things. They are the same thing, seen from the inside. There is a way of seeing the exile that makes it feel less like a penalty and more like a law of the shape of things, and it is worth pausing on gently in the dark. Every one of us is already travelling into the future and leaving people behind, all the time just at the same shared pace, so we do not feel the leaving as a loss. The tragedy of the forward time traveller is only the ordinary tragedy of being alive, sped up and made visible. We are all moving away from the people we have loved and lost second by second into a future that contains fewer and fewer of them. The time traveller simply does in an afternoon what the rest of us do across a lifetime, arrives in a world where the faces have changed, where the ones who knew us are gone, where we are a little bit of a stranger among people who came after. Forward motion has always been a slow goodbye. The black hole and the near light speed ship do not invent the goodbye. They only compress it until you cannot pretend it is not there. Even our real astronauts who gain only a whisper of a second come home to a version of this, and it is worth seeing, because it makes the exile concrete rather than theoretical. A person who spends most of a year in orbit returns to a world that has kept moving without them, friends who have changed, news they missed, a life on the ground that carried on in their absence. And though the relativistic part of it is measured in milliseconds, the human part of it is not small at all. They have been away. Things happened while they were gone that they can never quite catch up on. Now stretch that gentle, ordinary displacement to its limit. Imagine coming home not from a year but from a leap of centuries, and finding not friends who have changed but a world in which you are a rumour, a name in an old record if you are remembered at all. Every relationship you ever had closed and finished and filed away while you were, from your own point of view, gone for only an afternoon. The astronaut's mild dislocation and the time traveller's total exile are the same thing on a single scale, and the scale runs from the poignant to the unbearable. This is why, when people let themselves really imagine using the future door, the excitement so often curdles into something quieter and sadder. To go forward is to be the one who stays the same while everything you love ages and ends around your absence. It is to trade the entire warm crowd of your actual life for a ticket to a spectacle you will watch alone. And the strange thing, the human thing, is that almost no one actually wants that. The dream was never really about seeing the future. The dream, underneath, was always about the other direction, the one you cannot take, the going back, which is exactly where the physics turns from settled to unsettled, from a story about what we can do to a story about what the universe may or may not allow, and it begins with the discovery that troubled the man who understood time better than anyone alive. There is an old thought that fits here, that to live at all is to be always saying goodbye, and the time traveller only makes the saying loud. Every second you are handed is a second you must immediately give back, spent, gone, added to the pile of moments you can remember and never re-enter. The forward traveller simply gathers a lifetime of those goodbyes into a single afternoon, and feels, all at once, what the rest of us feel slowly enough to bear. It is the same loss. It is only the speed of it that changes, and the speed is the whole difference between a life and an exile. And so the wish to go back is really a wish to undo the one direction time actually runs, to swim upstream against the current that is carrying everything, including you, including everyone, steadily away. It is the most natural wish a person can have, and the most radical thing you could ask the universe to do. When you long to return to a moment, you are not asking for a small favour. You're asking reality to reverse the arrow that points through every atom and every memory and every law of heat and light. Given how enormous that request is, You might expect physics to answer it with a flat and final no to close the case, to tell us the past is simply gone and the reaching is futile. But that is not what physics says. Physics, when you ask it carefully, gives a far more disturbing answer than no. It says the door was never locked. It only perhaps has something standing behind it. And to understand that answer, we have to follow a logician into a rotating universe he built as a birthday gift. Part 8. The Equations That Do Not Say No. To understand why the past is such a strange and open question, you have to understand what Einstein's second theory, general relativity, actually is. It is not a vague set of ideas about gravity. It is a precise mathematical machine, a set of equations that describe how mass and energy shape the fabric of space-time, and how that shaped fabric in turn tells matter how to move. These equations are among the most successful in the history of science. They predicted the bending of starlight, the precise wobble of Mercury's orbit, the existence of black holes, the ripples we now call gravitational waves, all confirmed, often decades after the prediction, often to staggering precision. When general relativity speaks, the universe has a long habit of agreeing. So when general relativity says something disturbing, you cannot simply wave it away. You have to take it seriously, even when you would rather not. And in 1949, it said something very disturbing indeed to the one person least prepared to hear it. The messenger was a man named Kurt Gödel, one of the greatest logicians who has ever lived, and a close friend of Einstein's in their final years. The two of them used to walk home together across the grounds of the institute where they both worked, talking, and Gödel had been turning Einstein's own equations over in his formidable mind. For Einstein's 70th birthday, Gödel prepared an unusual gift. He had found a new solution to the field equations of general relativity, a fully valid, mathematically airtight description of a possible universe that obeyed all of Einstein's rules. It described a universe that rotates, spinning slowly as a whole. And in that rotating universe, Gödel showed, something is possible that should not be possible. A traveller could set out, always moving forward through their own local time, never doing anything strange from their own point of view, and by following a long enough loop through the spinning space-time, arrive back at their own starting point in both space and time. They could return to their own past. The equations did not forbid it. The equations produced it. Physicists have a name for these loops. They call them closed time-like curves. A time-like curve is just the path an ordinary object takes through space-time, always moving forward moment to moment as everything does. To say the curve is closed is to say it bends all the way around and rejoins itself, so that if you follow it faithfully, always forward, you end up where you began before you began. It is a path into your own history that never once requires you to move backward through time in any local sense. You always feel yourself going forward. The geometry of the universe does the rest, curving your forward motion into a circle that closes on the past. And Gödel had proven that general relativity, our best and most trusted theory of space and time, permits such paths to exist. He had proven, in the coldest and most rigorous way possible, that the laws of physics as we best understand them do not by themselves say no to time travel into the past. It is worth being clear about just how respectable these closed time-like curves are, because it would be comforting to dismiss them as a mathematical loophole, some flaw in the theory that a better theory will scrub away. They are not a loophole. They are a straightforward consequence of taking general relativity seriously, and general relativity has earned more trust than almost any idea in science. It told us light would bend around the sun before anyone had seen it bend. It told us the universe was expanding, that black holes were real, that space itself could ripple, and each time, sometimes decades later, the universe agreed. This is not a theory with a habit of being wrong at the edges, so when its equations calmly report that certain arrangements of matter and motion would let a traveller circle back to their own yesterday, always moving forward through their own time, never once reversing, you cannot honestly file that under fantasy. You have to file it under things our best physics permits and we do not yet understand. It helps to picture what a closed time-like curve actually is, because the phrase sounds technical, and the reality is almost dreamlike. Imagine your whole life as a single unbroken line drawn through space and time, starting at your birth and trailing along behind you through every place you have ever been, a thread that records where you are at every moment. For everyone who has ever lived, that thread runs one way only, always forward, never crossing itself, because you cannot be in 2 times at once and you cannot revisit a moment you have already left. A closed time-like curve is a thread that, without ever kinking backward, without your ever feeling yourself reverse, curves gently through a warped enough region of space-time until it loops around and rejoins itself. You walk forward the entire time, and you arrive at a moment you have already lived, and there, standing in it, is your younger self, still living it. The line of your life has become a circle. This is not a metaphor in the mathematics. It is a literal geometric object that Einstein's equations permit, given the right arrangement of matter and motion. The friendship between Einstein and Gödel is one of the quiet marvels of the last century, and it frames this discovery in a way worth lingering on. They were 2 refugees from a ruined Europe, walking home together most days across the grounds of the institute where they both had shelter, the physicist who had rebuilt our understanding of time and the logician who had shown that even mathematics contains truths it can never prove. Einstein once said, near the end, that he came to the institute mainly for the privilege of walking home with Gödel. And it was out of those walks, out of that deep and unusual friendship, that Gödel produced his troubling gift, a spinning universe born entirely from Einstein's own equations, in which the past lay open to anyone who travelled the right long loop. There is something almost tender and almost cruel in it, a friend proving to a friend that his life's work permitted the one thing that friend found hardest to accept. And what Einstein found hard to accept was not really the machine. It was what the machine implied about time. If you can travel to the past, then the past must, in some sense, still be there to travel to, which means it never truly vanished, which means the flowing, passing, one moment at a time quality of time that we feel so certainly may be a feature of us rather than of reality. Einstein had already half said as much, that the division of the world into past and present and future is a stubborn illusion. Gödel's universe pushed that thought to its edge. If the past is a place, then the whole sweep of history exists all at once, complete, in a great unchanging block, and our sense of moving through it is like the beam of a flashlight sliding along a mural that was always fully painted. That is a beautiful idea and a vertiginous one, and it is the philosophical ground on which every question about going back is built. If history is a finished painting, then reaching an earlier part of it is not raising the dead. It is only walking to another corner of a room that was always there. Hold that image of the finished painting for a moment longer, because it is the quiet hinge the rest of tonight turns on. If every moment that has ever happened still exists, fixed in place in the great structure of space-time, then the past you ache for has not been destroyed. It has only been left behind, the way a town you drove through this morning is still there after you have passed it, going on without you, unreachable not because it is gone, but because the road runs only one way. Whether there is any turning back onto that road is the question the machines were built to answer. Part of why this unsettles us less than it should, and part of why some physicists find it almost natural, comes from what relativity already says about time. In the picture that flows most naturally from Einstein's work, past and present and future are all equally real, all of them out there in a single 4-dimensional whole, and the sense that only the present moment exists, that the past has vanished and the future has not yet arrived, is a feature of how we experience reality rather than a fact about reality itself. Einstein said as much, near the end of his life, writing to comfort the family of a friend who had just died. The distinction between past, present and future, he wrote, is only a stubbornly persistent illusion. If that is true, if the past has not truly vanished but simply lies elsewhere in the great block of space-time, then travelling to it stops sounding like raising the dead and starts sounding like travelling to another place, a place that still exists, that is simply hard to reach. The equations say the path is possible. The philosophy says the destination is still there. All that is missing is the machine, and physicists could not resist asking what one would look like. Part 9. The Machines for Going Back. Once Gödel had opened the door, the search was on for a space-time that could produce closed time-like curves without needing an entire rotating universe to do it. Something more local, more like an object you could imagine building. And physicists found candidates, one after another, each a valid solution of Einstein's equations, each a genuine recipe for a path into the past, and each demanding some ingredient that nature seems extremely reluctant to provide. Following this trail is like walking through a gallery of impossible machines, all of them real on paper, none of them yet real in the world. There is the great spinning cylinder, first hinted at in a solution found back in 1937 and developed by the physicist Frank Tipler in 1974. Take an immensely dense cylinder and spin it so fast that its surface moves at a good fraction of the speed of light. A rotating mass does not just sit in space-time, it drags space-time around with it, twisting the fabric like a spoon turning in thick honey. Tipler showed that if such a cylinder were dense enough and long enough, and spun fast enough, the twisting could become severe enough that a traveller circling the cylinder could ride the dragged space-time around into their own past. The catch is brutal. To work cleanly, the cylinder has to be infinitely long, and nothing in the real universe is infinite. Make it finite, and the mathematics demands other exotic conditions to keep it from falling apart, and the machine slips out of reach. There are cosmic strings too, hypothetical threads of concentrated energy left over from the birth of the universe, thinner than an atom and denser than anything you can picture. The physicist Richard Gott showed in 1991 that if two such strings passed each other at close to the speed of light, the way they warped the space around them could open a path into the past for anyone threading between them at the right moment. Again, the ingredients, the strings themselves may not exist, and the conditions are beyond any conceivable engineering. And there is the strangest doorway of all, the one that has occupied serious physicists for decades. It is the wormhole. A wormhole is a tunnel through space-time, a shortcut connecting two separate places, and possibly two separate times, through a throat that bypasses the ordinary distance between them. Wormholes fall right out of the mathematics of general relativity. The problem is that a natural one would snap shut instantly, faster than anything could pass through, unless you could hold it open. And to hold it open, the equations demand a very particular and very troubling kind of material, something with negative energy, matter that weighs less than nothing, that pushes out where ordinary matter pulls in. We have the faintest hint that such negative energy can exist, in a subtle laboratory effect between two closely spaced plates, but only in unimaginably tiny amounts, nothing remotely like what you would need to prop open a tunnel a person could walk through. Suppose, though, that you could. Suppose you had your wormhole, its two mouths held open. Here is how you would turn it into a machine for reaching the past, worked out in 1988 by the physicist Kip Thorne and his students. Imagine it with me. You have two mouths of a wormhole, two openings you could step into, sitting side by side in your laboratory, connected through the tunnel so that stepping into one means emerging from the other. Now you take one of the mouths, load it carefully onto a ship, and fly it away at nearly the speed of light for a year, then bring it home. You already know what happens to a fast traveller. The mouth that made the trip has aged less than the mouth that stayed behind. The two openings still connected through the throat of the wormhole no longer share the same time. One of them is now, in effect, running behind the other, and so, when you step into the mouth that stayed home and emerge from the mouth that travelled, you come out earlier than you went in. You have walked into the past. You could do it again and again, looping, if you wished, back and back. It is a genuine time machine, built entirely from accepted physics, requiring nothing but a wormhole and a way to hold it open, and a great deal of patience. Before we leave this gallery of impossible machines, I want to dwell on the exotic ingredient they keep demanding, because the pattern in it is the real clue. Every serious route to the past that anyone has found runs, sooner or later, into the same locked cabinet, and the thing inside the cabinet is always some form of matter or energy that behaves backwards, that weighs less than nothing, that pushes where everything familiar pulls. Physicists call it exotic matter, and it is not a fudge invented to make time machines work. It shows up because holding a shortcut through space-time open, or twisting space-time hard enough to loop it, requires bending the fabric in a way ordinary matter simply cannot manage. Ordinary matter always curves space-time one way, the way that pulls things together. To make the loops, you need to curve it the other way, and for that you need a substance with negative energy. The universe does seem to allow the faintest whisper of such a thing, in a delicate effect where two metal plates held a hair apart in a vacuum feel a tiny push from the restlessness of empty space itself. But it is a whisper. It is nowhere near a shout, and every time machine on paper needs a shout. The gallery of would-be time machines is worth walking through slowly, because each one fails in its own instructive way, and the failures rhyme. The oldest of them dates back to 1937, when a physicist named Van Stockham solved Einstein's equations for an infinitely long, rotating cylinder of dense dust, and found, without at first fully realizing it, that the swirling space-time around it contained paths that looped back in time. Decades later, Frank Tipler made the connection explicit, and the same fatal word appeared: infinite. The cylinder must be endless to work cleanly, and the universe does not do endless. Then came Richard Gott's cosmic strings in 1991, those hypothetical threads of pure tension left over from the birth of the cosmos, thinner than an atom and unimaginably dense, which, if they existed and if two of them flew past each other at nearly light speed, could bend the space between them enough to open a loop in time. And there is the spinning heart of a rotating black hole, where the singularity is not a point but a ring, and where the mathematics hints that a traveller who threaded the ring might find closed time-like curves waiting, though no one can say what really happens in a place where the theory itself breaks down. The exotic matter these machines demand is worth understanding, because it is the single ingredient that keeps turning the possible into the impractical, and its scarcity is not an accident of engineering but something closer to a stance the universe takes. Ordinary matter, everything you have ever touched, curves space-time in one direction only, the direction that pulls things together, that makes apples fall and planets orbit and light bend inward around a star. To hold a wormhole open, or to twist space-time hard enough to loop it back on itself, you need the opposite, matter that pushes space-time outward, that has less than nothing where energy should be. We have seen the faintest hint that such a thing can exist. Squeeze two metal plates close enough together in a vacuum, and the restless quantum fluctuations of empty space produce a tiny region with slightly less energy than the true void around it. A whisper of negative energy, real and measured. But it is a whisper measured in the most delicate laboratory conditions, and a working time machine would need not a whisper but an ocean of the stuff held stable, on a scale no one has any idea how to reach. And there is a reason to suspect the difficulty runs deeper than mere engineering, a clue hiding in a place you would not expect. The speed of light, that famous barrier, is not really a limit on speed for its own sake. To travel faster than light, in a universe where the present is personal and tilted, is mathematically the same as arriving before you left, which is to say faster than light travel and travel into the past are secretly one and the same forbidden thing. So when you notice that reaching the past always seems to require impossible ingredients, and that outrunning light always seems to require infinite energy, you may be looking at two faces of a single quiet refusal, the universe declining by every route at once, to let effect run before cause. It has not written down a law that says so in plain words, at least not one we have found. But the pattern is there in everything, a door left technically unlocked, and yet somehow impossible to open, and the deepest objection of all is still waiting, the one that has nothing to do with matter or energy, and everything to do with whether a journey to the past could ever make sense at all. Every one of these shares the same two features, and together they are the real lesson. First, each is a legitimate solution of general relativity, not a cheat, not a mistake, a genuine description of a way space-time could be arranged so that the past becomes reachable. And second, each demands an ingredient the universe seems unwilling to supply in the needed amount, infinite length, or matter that weighs less than nothing, or a plunge past a horizon into physics we cannot compute. It is the same reason, at bottom, that the speed of light stands as a barrier, because to outrun light would itself be a way of arriving before you left, so that faster than light travel and time travel are secretly the same forbidden thing wearing two different masks. The pattern is too consistent to be an accident. The door to the past is never bolted exactly. It is simply hung on a hinge that requires an impossible substance to move. And even if you found that substance and moved it, you would run headlong into an objection that has nothing to do with matter or energy at all, an objection made of pure logic waiting on the other side. Part 10. The Grandfather in the Room. Suppose you have it. Suppose all the impossible ingredients have somehow been gathered, the wormhole propped open, the exotic matter found, the mouths flown apart, and a genuine path into the past lies before you. You step through, and you arrive in a time before you were born. And now the oldest objection in the whole subject rises up to meet you, an objection that needs no equations at all, only a cold and simple logic, and it has kept people from taking backward time travel seriously for as long as anyone has imagined it. It is usually told with a crime in it, and the crime is aimed at a grandfather. Here is the shape of it. You travel back to a time before your parents were born, and you find your own grandfather as a young man, and you prevent him somehow from ever meeting your grandmother. Perhaps you simply see to it that they never cross paths. The result is that one of your parents is never born, which means you are never born, which means you never grew up, never built a time machine, never travelled back, and were never there to keep your grandparents apart. But if you were never there to interfere, then your grandparents met after all, and your parent was born and you were born and you did travel back and you did interfere. Each possibility destroys the other. Your existence erases the trip, and the trip erases your existence, and the whole situation chases its own tail in a loop that can never come to rest. This is the grandfather paradox, and it is not a quirk about grandparents. It is the naked contradiction that seems to sit at the bottom of any journey into the past. If you can change what already happened, you can make the very trip that brought you there impossible, and logic itself appears to catch fire. For a long time, this was treated as a knockout blow, a clean proof that backward time travel simply cannot happen, because a thing that leads to contradiction must be false, and it is a serious objection. But if you look closely, the grandfather paradox does not actually prove that you cannot travel to the past. It proves something narrower and more interesting. It proves that you cannot travel to the past and then change it, because a changed past is a past inconsistent with the present you came from, and reality does not appear to tolerate two contradictory versions of the same history. Those are not the same claim. The first forbids the journey, the second forbids only a certain kind of freedom once you arrive. And that gap, the difference between cannot go and cannot change, is exactly where physicists have spent decades looking for a way through. There is a second paradox, quieter than the grandfather, but in some ways even more unsettling, and it does not involve breaking anything at all. It is the problem of things with no origin. Imagine a physicist who, late in life, is visited by a stranger who hands her a notebook containing the complete design for a working time machine. She spends years studying it, builds the machine and grows old, and then, as an old woman, she uses the machine to travel back and hand her own younger self the notebook. Follow the loop around. The younger physicist got the design from the older one. The older one got it from the younger one. At no point did anyone actually invent the machine. The knowledge simply exists, circling forever between the two versions of the same person, complete and functional and uncreated. Where did the design come from? The honest answer is that it came from nowhere. It is a loop of information with no source, a thing that exists only because it exists, an effect that is its own cause. Nothing is contradicted, no grandfather is harmed, and yet the mind rebels just as hard, because it seems to demand that something can be real without anything ever having made it real. The paradox of the uncreated thing deserves a second, sharper example because it gets under the skin in a way the grandfather never quite does. Imagine a young composer who receives, from a mysterious visitor, the manuscript of a symphony, a work of overwhelming beauty. She studies it, she performs it, she publishes it under her own name, and it becomes celebrated as her masterpiece. Then, as an old woman, she takes the manuscript, travels back in time, and hands it to her own younger self, the very visit that started everything. Now ask the only question that matters. Who wrote the symphony? The young woman did not, she was handed it. The old woman did not, she was only copying out the things she had been given in her youth. At no moment in the entire loop did any mind actually compose those notes. The music exists, it moves people to tears, and it was never created by anyone. It is a thing that is its own cause, an object with no origin, and the mind recoils from it as violently as it recoils from the grandfather, but for the opposite reason. The grandfather paradox is too much contradiction. The symphony is too little cause. One breaks the world by changing it. The other breaks the world by conjuring something out of an empty loop. To feel the full force of these paradoxes, you have to see that they threaten something. Physics holds even more sacred than any particular law, and that thing is cause and effect itself. Every piece of science, every experiment, every prediction rests on the assumption that causes come before their effects, that the world unfolds in an order, that reasons precede results. Strike a match and it lights, in that order, never the reverse. Push a swing and it moves, never moves and then gets pushed. This ordering is so deep in how we think that we barely notice it as an assumption at all, and yet backward time travel puts a knife directly to it. The grandfather paradox is a cause reaching back to abolish its own cause, an effect strangling the reason it exists. The self-created symphony is an effect with no cause at all, a result that reaches back to become its own reason. Both of them break the one rule the entire edifice of physics is built on, the rule that the world makes sense in a particular direction. That is why these puzzles refuse to feel like mere riddles, why they produce a genuine unease rather than a pleasant confusion. They are not asking you to solve a clever trick. They are asking whether a universe that permitted such things could still be a universe at all, whether it could still have a coherent history, whether the very notion of things happening for reasons could survive a loop in time. For a long time, most physicists concluded that it could not, that the paradoxes were a proof by contradiction that the past must be sealed, that any theory permitting time loops had thereby revealed a flaw in itself. It was a reasonable verdict. But it rested on the assumption that a time traveller arriving in the past would be free to do anything they liked, and a handful of careful thinkers began to wonder whether that assumption was the weak link, whether a universe might permit the journey while quietly forbidding only the contradictions, allowing you to arrive but not to break anything. Following that thread led somewhere that neither confirms your hopes nor kills them, but reshapes them into something stranger than either. It is worth admitting that for most of the last century, this was where serious physics simply stopped, hands raised, and declared the matter closed. The paradoxes seemed decisive. A theory that let you abolish your own past or conjure objects from empty loops had, most physicists felt, thereby exposed a defect in itself, a place where it must break down and be replaced by something wiser. And that remained the respectable position for a long time, that closed time-like curves were a flaw to be explained away rather than a possibility to be taken seriously. What changed was not the discovery of any new fact, but a shift in the question being asked. A willingness to stop assuming the traveller could do anything at all, and to ask instead what a universe would have to be like if it permitted the trip but never the contradiction. That single change of question opened a door that logic alone had seemed to slam. Together, these two paradoxes are the reason that, long before anyone wrote down a single equation, human beings had already decided that the past must be off limits. It is not that we cannot picture a machine. It is that when we picture what would happen after we stepped out of it, we seem forced to choose between a reality that tears itself apart in contradiction and a reality where things assemble themselves from nothing, and both of those feel like the universe cheating. This is where the argument stood for a long time, at an apparent stalemate, the physics saying the door is open, and the logic saying the door leads only to nonsense. But a stalemate is not a proof, and a handful of physicists refused to accept that logic had really closed the case. They asked a more careful question. Not can you break the past, but what happens if the universe simply does not allow the breaking, if the only trips it permits are the ones that hold together? And the answer they found is stranger and more elegant than either the paradox or the flat denial. Part 11. The universe refuses to contradict itself. In the 1980s and early 1990s, a group of physicists, among them the Russian theorist Igor Novikov, worked through the problem of time loops with unusual care, and they arrived at a principle so simple to state that it sounds almost like a trick, and yet it dissolves the grandfather paradox completely without forbidding the journey. The principle is this: the only histories that can happen are the ones that are self-consistent. Events are free to unfold in any way at all, except a way that contradicts itself. A trip into the past is allowed, fully allowed, on one condition. Whatever you do back there must be consistent with the history you already know, because that history already includes your visit. You do not arrive in a fresh past waiting to be rewritten. You arrive in the past that already happened, the one that always already had you in it. Think about what this does to the grandfather. Under Novikov's principle, you can travel back and stand in the same room as your young grandfather, but you will not succeed in keeping him from your grandmother, because he did meet her. That is a settled fact. It is why you exist to be standing there at all. If you raise a gun to stop it, the gun will jam, or your aim will be spoiled, or the man you're so sure is your grandfather will turn out to be a stranger, or, in the strangest and most poignant version, it will be your own clumsy interference that accidentally introduces your grandparents to each other in the first place. Something, always, will conspire to keep the history consistent, not because a mysterious force reaches in to stop you, but because the inconsistent version is simply not among the things that can happen. The universe does not need a policeman to prevent contradictions. It prevents them the way a circle prevents itself from being a square, by definition, at the level of what is even possible. Physicists tested this idea not with grandfathers, but with a cleaner example, a billiard ball rolling toward the mouth of a wormhole time machine. The worry was a mechanical version of the grandfather paradox. Let the ball roll in, travel back in time, come out of the earlier mouth and strike its own younger self so as to knock it off course, so that it never rolls into the wormhole to begin with. A clean physical contradiction, no free will required, and when they worked through the mathematics carefully, they found something that has stayed with everyone who studies it. For every setup that seemed to create a paradox, there always existed at least one self-consistent solution, a way for the ball to travel back and interact with its younger self that nudged its path without ever preventing the trip. The older ball's glancing blow becoming the very reason the younger ball rolled into the wormhole at just the right angle. The paradoxical outcomes were not solutions to the equations at all. Only the consistent ones were. The physics, left to itself, simply refused to produce the contradiction. Sit with what this would mean if it is true, because it is one of the strangest ideas in all of science, and it is stranger the longer you hold it. It would mean you could go back. It would mean the door to the past is not only unlocked in principle, but genuinely passable. And it would mean that you could never ever change a single thing, because everything you did there was always already part of how things turned out. If you travelled back to save someone, then your attempt to save them was always a thread in the story of how they were lost, woven in from the beginning, and you were always going to fail in precisely the way that led to the present you remember. You would have complete freedom to act and no freedom at all to alter, because your actions in the past are not additions to history, they are already in it. You would not be rewriting the story. You would be discovering from the inside that you were always one of its characters. What makes this idea so hard to hold in the mind is the way it quietly rewrites the meaning of the word can. In ordinary life, we believe that if a person is holding a loaded gun and is free to pull the trigger, then they can pull it, whether or not they actually do. Novikov's principle does something almost violent to that intuition. It says that a time traveller standing over the young grandfather genuinely could pull the trigger, is physically able, is not restrained by any visible force, and yet it will not happen, because a universe that permits the trip does not permit the contradiction the trigger would create. The freedom is real, and the failure is certain, both at once, and holding those two together is like trying to look at the front and back of a coin at the same instant. The physicists who worked this out, among them Kip Thorne and his collaborators, did not arrive at it as a philosophy. They arrived at it by asking what solutions their equations would actually allow, and finding again and again that only the self-consistent ones survived, while the paradoxical ones were simply not solutions to begin with, no more real than a number that is both even and odd. This is where time travel stops being about machines and starts being about fate, about whether the future and the past are already written. If the only journeys the universe permits are the ones that were always part of history, then a time traveller is not an author revising a manuscript. They are a character who has always been on the page, whose every action, however freely felt, was already printed there before they read it. And the unsettling thing is that this may not be special to time travellers at all. It may be the ordinary condition of everyone, hidden. Perhaps the past is fixed and the future is fixed, and the sensation of an open, undecided moment is simply what it feels like from the inside to be a part of a story you cannot see the ending of. Time travel just makes the fixedness visible, drags it into the light, forces you to look at a future that is somehow both yours to choose and already done. Most people can live a whole life without ever confronting that possibility. The time traveller confronts it the instant they step out of the machine and realise they cannot change the thing they came to change. There is a reason this idea, cold as it is, has a strange gentleness to it as well, and it is worth naming before we leave it. If the past cannot be changed, then it also cannot be spoiled, cannot be undone by accident or malice, cannot be stolen from you by any traveller who might wish to reach back and unmake what you hold dear. The moments you love are, on this view, permanent, sealed into the finished structure of history exactly as they happened, safe from every possible interference precisely because interference that changed them was never among the things that could occur. It is the same fact that denies you the rescue you long for, seen from its other side. You cannot go back and mend the broken thing, but no one can go back and break the whole thing either. The past is closed to your hands, and that is a grief, and it is also, quietly, a kind of protection. Carry that back to the human version and feel how it reshapes the meaning of freedom. Under this principle, you could travel to the past, walk its streets, speak to the people there, and everything you did would be real and freely chosen in the moment, and yet none of it could ever come out differently than it already had, because the history you remember already contains everything you are about to do. You would not be a visitor arriving in an unwritten scene. You would be stepping into a role you had, unknowingly, already played, the actions you take now having always been part of the past you came from. If you went back to save someone, your going back was always one of the reasons they were not saved, folded into the story from the start. There is a strange, still peace in this, the peace of a history that cannot be broken, that will hold together no matter what, that already includes you and every choice you will make within it. And there is a grief in it too, the grief of learning that even with the door open, even standing in the very moment you ache to return to, you could not change the one thing you came to change. But not every physicist believed the universe solves the paradox this gently, and the alternatives are where the story turns colder. Part 12. Or maybe the universe slams the door. The Novikov principle keeps a single timeline whole by forbidding you to change it. But there is another way out of the grandfather paradox, and it appeals to something at the very root of physics, where quantum mechanics has been whispering for a century that reality may not be a single thread at all. In the 1990s, the physicist David Deutsch applied this idea directly to time travel, and it turns the whole problem inside out. Suppose that the universe is constantly splitting, branching into countless parallel versions, each one a slightly different unfolding of what could happen. Then when you travel into the past, you do not necessarily arrive in your own past. You arrive in one of the branches, and it may not be the branch you came from. And if that is so, the grandfather paradox simply evaporates. Follow it through, because it is oddly liberating after the iron grip of self-consistency. You go back and you prevent a grandfather from meeting a grandmother. In this picture, you have not created a contradiction, because the grandfather you interfered with was not the one on your own timeline. He belongs to a branch that now runs forward without you in it, a world where that particular grandchild is never born. Meanwhile, the branch you came from, the one where the meeting did happen, and you were born and you left, still exists, untouched, complete. You changed a past, just not your past. In this version, the past is genuinely rewritable. History really can be altered, but only ever the history of some other world, while your own remains exactly as it was. You could go back and save the person after all, and they would live, radiantly, in a timeline you can visit but can never truly return home to. Because the home you left is a different branch entirely. It gives you the change Novikov denied you, and takes away in exchange the only thing that made the change worth wanting, that it be your world that is healed. And then there is the possibility that all of this careful reasoning is beside the point, because the universe never lets a time machine switch on in the first place. This was the position of Stephen Hawking, and he gave it a name, the chronology protection conjecture, in 1992. His idea was that even though general relativity permits closed time-like curves on paper, the deeper laws of physics, the quantum ones we have not yet fully written down, will always intervene at the last moment to destroy any time machine just as it is about to begin working. The mechanism he proposed has a certain grim elegance. As a loop in time is about to close, empty space itself, which is never truly empty but always seething with faint quantum fluctuations, would feed those fluctuations around and around the forming loop, amplifying them without limit, building to an infinite surge of energy that blows the machine apart in the very instant of its birth. The universe, on this view, defends its own history not with logic and not with parallel worlds, but with a kind of automatic circuit breaker, tripping every time reality gets too close to folding back on itself. Hawking summed up the spirit of it with a joke that was also a serious claim. The laws of physics, he said, conspire to keep the world safe for historians. He even ran an experiment of a sort, and it is the most charming thing a great physicist ever did with a serious question. In 2009, Hawking held a party for time travellers. He arranged a room with balloons and champagne and a banner reading "Welcome, time travellers," and he set out chairs for his guests. The trick, the whole point, was that he sent out the invitations only after the party had already taken place. He told no one in advance. The only way anyone could possibly have known when and where to come was to read the invitation in the future and then travel backward to attend. Picture him there, in the quiet room, the champagne going flat, the balloons drifting, a man who had spent his life thinking harder than almost anyone about the nature of time, sitting among the empty chairs, waiting, with a smile, to see if anyone would walk through the door. No one came. The chairs stayed empty. and Hawking called that empty room a piece of experimental evidence, light-hearted but pointed, that travel to the past is not possible, at least not for anyone, ever, in the whole future of the universe, who would have wanted to accept his invitation. The people who claim it is already happening deserve a fair hearing before the physics quietly closes the door on them, because their stories reveal what we want to be true. Every few years, a photograph circulates that seems to show someone out of place in an old crowd, holding what looks like a modern device, and it is offered as proof that travellers from the future walk among us. Every one of these, examined closely, turns out to be something ordinary: a period camera, an old hearing aid, a trick of clothing and grain. Around the turn of the millennium, a figure appeared on the early internet claiming to be a soldier from decades in the future, sent back with warnings and predictions, and the predictions, checked against the years that followed, simply did not come true. Others insist that a great particle collider is secretly tearing open portals in time, when in truth such machines, for all their power, work on single particles at energies staggeringly far below anything a time machine would require, and they bend the pairs of protons, not the shape of history. And many people take their own shared false memories, the sense that some fact of the past has been quietly altered, as evidence that the timeline itself was edited, when the far simpler explanation is that human memory reconstructs rather than replays, and that many minds can misremember the same thing in the same way. Hawking's proposed mechanism for sealing the past deserves a closer look, because it is one of the eeriest ideas in physics, the universe defending itself with its own emptiness. Empty space, in the modern picture, is not truly empty. It seethes, everywhere, always, with faint fluctuations, pairs of particles flickering into being and vanishing again, a restless quantum foam underlying even the deepest void. Ordinarily, these fluctuations are harmless, invisible, averaging out to nothing. But Hawking argued that if a region of space-time were about to fold into a loop, if a time machine were about to switch on, those fluctuations would find themselves able to travel around the loop and around again, each pass adding to the last, building without limit, until the accumulated energy became a catastrophe that ripped the region apart before the loop could ever close. The machine would destroy itself automatically in the instant of its birth, not because anyone forbade it, but because the structure of the quantum vacuum will not tolerate the fold. It is a circuit breaker built into reality, tripping every time the world comes too close to letting effect precede cause. But, and this is the honest heart of the whole subject, Hawking could not prove it. He called it conjecture, deliberately, because proving it would require the one thing physics still does not possess: a complete theory uniting the quantum world of the very small with the gravity of the very large. Time machines live precisely at the seam between those two domains, in the region where a warped space-time meets the trembling of the vacuum, and that seam is exactly where our understanding gives out. General relativity alone says the loops are allowed. Quantum mechanics, alone, cannot settle the matter. Only a theory of quantum gravity could tell us for certain whether the past is sealed by Hawking's surging vacuum or left quietly open after all, and a century of the most brilliant minds in science has not managed to build that theory. So we are left, genuinely, not knowing. Not knowing whether the empty chairs at Hawking's party were a law of nature or merely the absence of anyone with a machine. The question is not closed. It is only for now unanswerable, and there is a peculiar dignity in a science honest enough to say so. What stands out is that every one of these beliefs reaches for the same forbidden thing, a way back, a sign that the past is not truly sealed, and that the sober physics answers each of them with a narrower and stranger truth than the fantasy. There are no confirmed visitors from the future, and there is a clean reason to expect none, because no machine can reach a time before it was built, and none has been built. Scientists have not sent anything into its own past. What they have managed is subtler and more honest. In recent years, physicists have simulated time loops in the laboratory, using carefully arranged quantum systems that obey the same equations a genuine loop would, letting them study how information and consistency would behave without ever actually sending a particle backward through time. These experiments do not build time machines. They build models of them, the way a wind tunnel builds a model of a storm, and what they find so far is consistent with a universe that permits the equations but guards the reality. The honest verdict remains suspended between the open door and the possible guard, and that suspension is not a failure of the story. It is the truest thing we can say, and it is where we must at last come to rest. Part 13. The only direction that opens. So let us gather it all up, here at the end, in the quiet. We began with a word you thought you understood. Time travel, a thing you had filed away with the other beautiful impossibilities. And we found that it splits cleanly in two, into a direction that is real and proven, and a direction that hangs in a genuine gap in human knowledge, and that the two could hardly be more different from each other. Forward is settled. It is measured. It is happening to you at this very moment, and it can be made to happen faster. Backward is the open wound of the subject, permitted by our best equations, blocked by paradox, walled off by exotic requirements, perhaps guarded by a law we cannot yet read. And running underneath the whole of it is that small phrase from the very start, the one you have carried through every part of this, 1 second per second. That is the rule, the whole rule, stated as plainly as physics can state it. You may travel faster than 1 second per second into the future, fly near the speed of light, or fall close to something monstrously heavy, and you can turn one of your seconds into 1,000 of the world's, leaping as far ahead as you have the means to go. You may never travel slower than 0. You may never make the number negative. The arrow that carries you forward can be sped up without limit and slowed toward a crawl beside a black hole, but as far as anyone has ever been able to prove, it cannot be reversed. The future is a country with its gates thrown open and a road running only inward. And the past, the one place every human heart actually strains toward, is the one place the road may never reach. Think back to that black hole and the ship holding station at its edge, the universe wheeling and racing outside the glass while a single calm afternoon passes inside. That is the door to the future, wide open, generous, waiting for anyone with the courage and the fuel to use it. And think of the other door, the one behind you, the one Gödel showed had no lock, the one the wormhole machine could almost reach except for the moment it was built, the one Novikov said you could pass through but never change, the one Deutsch said led only to someone else's world, the one Hawking sat waiting beside in a room full of empty chairs. That door has no lock, but it may have a guard, and we do not yet know its name, because we do not yet have the theory that would let us read it. The most our physics can honestly say is that the past is not obviously forbidden and not obviously reachable, and that the difference between those two is a hole in human understanding shaped exactly like the thing we want most. We can go back. It is the oldest wish there is, older than physics, older than the wheel, as old as the first person who lost something and could not stop reaching for it. Go back to the room. Go back to the face. Go back to the ordinary hour you did not know to hold. Tonight we have taken that wish and pressed it against the actual structure of reality, and the honest answer that came back is not a yes, and it is not a no. It is a maybe wrapped around a wall. The universe permits us freely and provably to run ahead of everyone we love and arrive alone in their future. It has not decided, or has not told us, whether it will ever let us turn around. Maybe some far civilization, ages from now, will gather the exotic matter and prop the tunnel open and find the past standing quietly available all along. Or maybe, at the last instant, empty space itself will surge and tear the machine apart, and the chairs will stay empty forever, and forward will remain the only direction that opens. There is one more thread worth naming before you let this go, and it is the deepest reason the past feels so different from the future in the first place. Everything in the universe that happens spontaneously runs in one direction, from order toward disorder, from hot toward cold, from the intact toward the broken. A cup falls and shatters and never leaps back together. Heat spreads out through a room and never gathers itself back into a warm spot. This one-way slide from the more ordered to the less ordered is the closest thing physics has to an arrow drawn on time itself, and it is why you remember the past and not the future, why cause comes before effect, why the world has a before and an after at all. To travel backward would mean, in some sense, running against that universal current, and perhaps that is the real reason the past resists us so completely, not a locked door so much as a river that only flows one way, carrying everything, including memory, including us, downstream. The future is simply the direction the current runs. The past is the direction it has already left behind. And so the two possibilities that hang over this whole subject are these, and we cannot yet choose between them. Either the past is genuinely reachable, standing quietly open behind an impossible hinge, waiting for some far civilization with patience and exotic matter enough to prop the tunnel and step through into a history that was always going to include their arrival. Or the universe, at the last instant, always closes the loop before it forms, some deep law we have not yet written surging up out of empty space to tear the machine apart in the moment of its birth, keeping the world forever safe for historians and forever closed to the grieving. One of these is true. We do not know which, and we will not know which until we hold in our hands a theory that unites the very small and the very heavy, a theory a century of the finest minds has not yet found. The door has no lock. It may have a guard. Its name is written in a language we cannot yet read. So let this be where we finally rest, not on an answer, but on the strange and honest place the physics actually leaves us. We wanted, all of us, coming into this, a simple verdict. We wanted to be told either that time travel is impossible, so we could set the longing down, or that it is possible, so we could begin to hope. The universe has refused to give us either. It has told us instead that one direction is wide open and the other is a genuine unknown, that we can run ahead as far as we dare and cannot say whether we may ever turn around, that the door behind us has no lock and may or may not have a guard whose name we cannot read. That is not the tidy ending anyone wanted, but it is the true one, and there is something worth honouring in a science brave enough to stand at the edge of its own knowledge and say, plainly, we do not yet know. And perhaps that is enough, more than enough for one night. We set out to test the oldest wish there is against the coldest facts we have, and we found neither the flat refusal that would let us stop hoping nor the clean promise that would let us begin. We found a universe that carries us forward without asking, and keeps its counsel about the way back, a universe honest enough, in the mouths of its most careful students, to admit the edge of what it knows. That is a rarer and finer thing than a tidy answer. It is the truth, held open, still warm, unfinished. Either way, notice this, before you drift off. You're still travelling. You've been the whole time you've been listening carried forward at 1 second per second, into a future arriving now and now and now, each moment new and each moment gone. You cannot stop it and you would not really want to, because that forward motion is the same thing as being alive. The past is closing softly behind you as it always has, moment by moment, and whether it is a door merely shut or a door truly sealed is a question the universe has kept to itself. So hold the people who are here, in this second, this one, the only one you are ever actually given. The future will keep opening on its own, and if the way back is ever found, it will not be tonight, and it will not reach this room, and there is a strange peace in that, in letting this moment simply be the one you are in, 1 second per second, the only direction that opens, carrying you gently on.